Okay, here's a weird one for you. What does your grade on a test have in common with, say, your phone number? I know, it sounds like the start of a bad joke, but the answer is actually one of the most fundamental ideas in all of math. It's a concept you literally use every single day. And by the end of this, you're going to see exactly what it is and why it's so incredibly powerful.
So let's just think about connections for a second. Simple pairings between two things. To show you what I mean, we're going to look at three super quick examples. See if you can spot the pattern, the common thread that links them all.
First up, think about a student and their grade on a test, right? You've got one thing, the student, and it's paired up with another thing, the grade. Simple enough. Okay, how about this one? A person and their phone number. It's really the exact same idea, isn't it? A specific person is linked or paired with a specific string of numbers.
And for our last one, just picture the link between a city and its temperature at any given moment. So in all three of these examples, we're just looking at a really clear, distinct connection between two pieces of info. You see the pattern now? So a student and a grade, a person and a phone number, a city and a temperature, all of these pairings, they all share the exact same underlying structure. And, you guessed it, in math, we've got a formal name for these kinds of connections. It's called a relation. And the definition? It's almost shockingly simple. A relation is just a set of ordered pairs. That's it. It's just the fancy mathematical way of saying, hey, these two things go together.
And looking at this table really makes that abstract definition concrete, right? Here we've got our set of ordered pairs. You've got Abel paired with 85, Sarah paired with 92, Jonas with 85, and Hannah with 78. This whole collection of pairs, all of it taken together, that is the relation.
All right, so now we know what a relation is. Let's kind of peek under the hood and break it down into its two essential parts. Because every single relation has a set of inputs and, a matching set of outputs.
And these parts have names. We call them the domain and the range. The domain is just a fancy word for all the first things in our pairs, the inputs. So in our example, it's the list of students, Abel, Sarah, Jonas, and Hannah. And the range? Well, that's the set of all the second things, the outputs, or the test scores. So that's 85, 92, and 78. But wait a minute. You're probably looking at that and thinking, hang on, Abel and Jonas both scored an 85, so why is 85 only listed once in the range? That is an excellent question, and you've just hit on a really, really important rule here. Yeah, let's just focus on that number, 85. It definitely shows up twice in our original list of pairs, right? Once for Abel and again for Jonas. So here's the deal, the really crucial point. The range is the set of all the unique outputs. That's the keyword, unique. So even if a score like 85 showed up a dozen times, we would still only list it one time when we write out the range. Think of it this way. We're just listing what the possible outcomes were, not counting how many times each one happened. Okay, so we've got the definition. We've got domain, we've got range, we've got the basics down. Now, let's see this stuff out in the wild. I promise, once you know what you're looking for, you are going to start seeing relations absolutely everywhere. I mean, they can be purely mathematical, right? Like a set of points you'd plot on a graph. They can be commercial, like pairing an item in a store with its price tag. They can be geometric, pairing a shape with how many sides it has. Or even academic, like pairing a student with all the classes they're taking. Every single one of these, they're all just different flavors of a relation. They're all just a set of ordered pairs. So yeah, we've established they're everywhere. But so what? Why does this simple idea of just pairing things up, why does it matter so much? What's the big picture here? Well, let's circle back to that core definition one last time, because its simplicity is exactly where its power comes from. A relation is simply a set of ordered pairs. All we're doing is creating a formal mathematical way to say a connection exists here. And that, right there, is why this matters so much. Relations are the foundational building blocks for describing and analyzing patterns in the world. Seriously, think about it. Before you can plot a graph, or build a database, or analyze any kind of data, you have to have a way to describe the connections within that data. Relations are that first, absolutely essential step. Which leaves us with one last, kind of juicy question to think about. If pretty much any set of pairs can be a relation, are some relations more
predictable than others? I mean, what if we had a special, more well-behaved kind of relation where every single input gives you one and only one possible output? Well, that question right there, that's the key that unlocks the next giant topic in mathematics.